exponent books. Here we go. I want you to look at this page right here that we filled in. This is pages 3 and 4. 3 and 4. Today we're going to work with division. So I want to leave a little bit of a gap. Leave a little bit of a gap on this page, and let's jump down to, like, I don't know, leave about this much of a gap, and we're going to jump down about midway through the page there. If I gave you this problem, x to the 7th divided by x cubed. And again, I left a little bit of a gap there in my page. I didn't just do it right at the top. What does x to the 7th mean? X times itself 7 times. X times x times x is x times x. X times itself 7 times. X to the 3rd means x times itself how many times?
3.
X times itself 3 times. Now, we could simplify this that we have right here. What is x divided by x? What's 2 divided by 2? 1. What's 8 divided by 8? What's x divided by x? 1. Anything divided by itself is always 1. So here I've got x divided by x. That's going to simplify to 1. I've got another x that I could simplify. And I've got a third x that I could simplify. How many x's am I left with? 4. How do we write that answer? X to the 4th power. What's my shortcut?
You subtract the top from the bottom.
Subtract the top exponent from the bottom exponent. I really took 7 minus 3. I took the top exponent of 7 minus the bottom exponent of 3. Equals x to the 4th power. So up above this example, I want to write in what we did. I'm going to write, when dividing powers with like bases, treat the division bar like a giant subtraction sign. Doesn't this division bar, this sign right here, means division, correct? Looks like a subtraction sign. That's an easy way for you to remember that you're going to subtract when you divide. When we did PMA, we said power to power you multiply, multiply your bases you add. Turn around, please. All the way around. This time when we're dividing, this division bar is telling us that we are subtracting the exponent. So that's what we're going to write it. When dividing powers, with like bases, treat the division bar like a giant subtraction sign. When dividing powers with like bases, treat the division bar like a giant subtraction sign. That is all we're going to put into our book now. Now let me ask you a question. What if we had x to the 3rd on top and x to the 7th in the denominator? It would be -4, and that opens a whole new can of worms. None of our exponents are going to be negative just yet. We're going to start that next week. We'll say that for then. Today they should all be positive exponents. So, did everyone get a notes sheet? All of today's examples on them. So it looks something like that. So let's go through and simplify some of these expressions. Example 1, we have x to the 4th divided by x squared. We are dividing, so we would subtract those exponents. X to the 2nd power. Now, do we really need to show that first step where I did 4 minus 2?
No.
No, I hope you can do that in your head. If you need to see it, do it, but you should be able to subtract those in your head. Example 2, x to the 5th divided by x squared is really x to the 3rd. 5 minus 2 is x to the 3rd. We always take the top exponent minus the bottom exponent. Example 3. I've got 2 variables involved. Does that make a difference?
No.
It shouldn't. 4 minus 2, looking at my a's, 4 minus 2 is 2, a squared. B, 7 minus 5, 2, a squared, b squared. Example 4, I have x squared in the numerator, but I don't have an x in the denominator. What does that mean I do with it? Just carry it across. There's nothing to simplify it with. Now I have y divided by y. What did we just say x divided by x is? Not 0. It's 1. They cancel out. It's not y to the 1st. It cancels out. We have z to the 2nd. 3 minus 1 is 2. X squared, z. Excuse me, x to the 4th, z squared. I'll explain why those y's cancel out next week when we start talking about 0 exponents. We're not quite ready for that just yet. Example 5. In example 5, we have a coefficient of negative 2/6. Negative 2 and 6 are not exponents, so please don't subtract them. They're coefficients. Simplify. What goes into 2 and into 6? 2 does. 2 goes into negative 2. Negative 1 times. And 2 goes into 6. 3 times. So we have negative 1 in the numerator. And we have 3 in the denominator. The rest of it is just like we've been doing. So we have x to the 4th divided by x cubed. We're dividing. Subtract those exponents. 4 minus 3 is 1. When you subtract exponents, when you divide variables, that variable always goes to the numerator. It's not with the denominator. The y's, what's going to happen there? Cancel. Y divided by y, it's going to become 1. Z cubed divided by z. 3 minus 1 is 2z squared. I will take your answer written this way, or you could have this. Negative x z squared all divided by 3. Either one, they're the same thing. So if you're grading an assignment and somebody had one or the other answer here, I would both be okay. Cool.
Why do you put on top?
Why is what on top? Negative?
No, why do you put the, yeah, variables on top?
When you subtract them, think about, isn't there more x's on top? There's 4, like x's, we had 4 x's to start with, right? And 3 in the denominator. We had more x's on top, so it will remain at the top. And 7. We learned about order of operations last year in Algebra A. The order of operations still apply. They have not disappeared. You still need to do your parentheses first. So inside the parentheses, is there anything we can simplify? Yes. I'm not going to worry about the 4, this exponent just yet. But looking at your x's, we have x divided by x. What's going to happen there? They're going to cancel. Y squared divided by y. Y to the 1st. Remember, you subtract them, it goes to the numerator. There's more y's on top. We have more y's on top, so it stays at the top. What about z? Where's it going to go? It's going to go to the denominator. This is all raised to the 4th power. So now we'll take everything to the 4th power. This is what we did before. We had a power to a power. We have 3 to the 4th. We have y to the 4th. We have negative 2 to the 4th. And we have z to the 4th. So 3 to the 4th power. 3 times 3 times 3 times 3, it is 81. Y to the 4th is going to remain y to the 4th. Negative 2 to the 4th, positive 16. Z. Number 7. We can again simplify before we take care of our exponent, so I'm not going to worry about the 3 on the outside just yet. Starting with my fraction, negative 2 fourths, what goes into negative 2 and 4? 2. 2 goes into negative 2, negative 1 times, and 2 goes into 4 twice. So negative 1 divided by 2. A to the 4th divided by A is A to the 3rd. B to the 1st. 2 minus 1 the 1st. What's going to happen to C's? Cancel. And D, nothing is there to simplify with the D, so it stays in the denominator. All that is going to be cubed. Now take everything to the 3rd power. 1 to the 3rd power. A cubed to the 3rd power. 2 to the 3rd power. Negative 1 to the 3rd is negative 1 times negative 1 times negative 1, which is A cubed is A to the 9th. All divided by 2 to the 3rd, or 8. D to the 12th. And of course, you could also write this as negative A to the 9th. D to the 3rd. All divided by 8. Guys, you've got to remember those rules from before. The PMA, power to power, you multiply your basis, you add. We've added a new one with division. If you're dividing, you subtract. We're going to add, there's still additional rules that we need to learn. Negative exponents, zero exponents. We still need to add a few more into these rules. So don't forget the ones we've already learned. The assignment for tonight is going to be on a worksheet. Do 3 problems. You are pencil?